A Wrinkle in Time. You'll now be introduced to how important time is in computer forensics and internet investigations, as well as regular cyber investigations. Why do we care about time when it comes to forensics and cyber investigations? We have to use time and data to, well, determine who used a computer and when a computer was used, how long a computer was used. You need to determine when an event occurred or when files used or a source came into a file, when a call or text was made or sent. Everything when it comes to investigation or a case deals with when something happened and what happened when, or who did something when. Especially in cases where you have multiple people on a computer or phone, you need to identify whose activity occurred during a certain time period and who you can attribute that to. So as you can see, time becomes very important inside these investigations and analysis. So what do we cover in today's class? We're going to talk about the general information on time, so you get an understanding of both terms and the different places and different ways time is recorded. You'll get a brief history of time, the type of times there are, the zones, daylight savings time, how daylight savings time has changed throughout the years. Also sources of time, and I mean not just the watch on your wrist, both network and internet sources for time. And also you'll be learning about some of the places that we can find time and dates on a PC, which ultimately that is the artifact that you're trying to determine when you're doing an investigation. All dates and times in a computer are dependent upon either its clock being accurately set and running. This can apply to the suspect's computer clock, the clock of a server, or even that of your own forensic machine. If either one of those is off, you need to be able to explain why it's off and where it got its time from. A clock that is set correctly now may not have been set prior. In other words, just because a clock shows perfect now, did somebody go in, alter the clock's date and time, produce some evidence, then go back and re-alter the clock's date and time on the system to make it correct again? We've seen that happen a lot in different forensic examinations, especially examinations about email. Most people think there's only one type of time. Oh, there's many. There's train time. There's London time, or the Big Ben time. There's a time clock. There's multiple time zones in different parts of the world in those clocks. Then there's time versus money. All those come into play. So let's start off with discussing base time. We'll be talking in the next couple slides about GMT, otherwise known as Greenwich Mean Time, which most people know about, but they refer to it as GMT. Then there's Universal Time, or UT time. And then another one that everyone refers to as UTC, but they refer to it in the phrase Coordinated Universal Time, whereas in reality, people think it means Universal Time Coordinated. So we'll start off talking about Greenwich time, or what is commonly known as Greenwich Mean Time, GMT. Yes, it's out of Greenwich, England. It started in 1884, and it is on the zero longitude. So they believe the day begins there at longitude 0. And of course, the Royal Observatory in Greenwich, England is one of the properties that's on longitude 0. GMT, one of the properties of GMT is that it remains the same all year round. Daylight savings does not affect it. It is the starting point of time. Well, okay, sort of the start. But setting your time to London does not mean GMT. Why do you think that is? London observes daylight savings time, so that at least a couple months during the year, if you set it to London time thinking it never changes, you'd be off an hour. So now we have universal time. It's another name for GMT, really, but it's done by star observations. This is the traditional time that people are used to, and this goes all the way back to early, way before 1884. And last but not least, we have coordinated time, or UTC. It sounds a little different, but it's probably the one that you'll be using the most going forward. You'll always be setting your clocks to UTC when it comes to log files and things like that, so that you have a general setting for all the log files that you're looking at, or file stamps you're looking at for file dates and times. That is consistent. You won't have to think in your mind, okay, East Coast, West Coast, 3 hours difference. Everything would be UTC. It did replace the GMT as the world standard back in 1986 because it's based on an atomic clock rather than the Earth's rotation. So to align it with traditional time and based on Earth's rotation, when that sun first pops the horizon, the time's adjusted once a year, and we're talking microseconds a year. Here's a good question for you. At 12:01, just past midnight, is it AM or PM? It's just past midnight, so it's AM. So let's start talking about our time formats. We use two basically worldwide, and we have the first one, which is 24-hour format, which is sometimes referred to as the military format, but it starts at 0000. Midnight is 0000, and 12 noon would be 12:00. That means the day ends at 23:59:59. The civilian side uses a 12-hour format, and it would be AM for anti-meridian. That starts at 1 minute past midnight, and PM, post-meridian, that starts 1 minute past noon. To see the conversion and to make it a little bit easier, we've drawn a graphic here that shows the different times during the day and what it is in both 24-hour format and in 12-hour format. As you can see, at midnight, it is 12 and 12-hour format and 0000 in the 24-hour format. Whereas 6 o'clock or 6 p.m. would be 1800 hours in the 2400 format. You thought you'd get away without another question? Wrong. It's 12 o'clock in the morning. Is it AM or PM? Okay, it was a trick question, granted. At 12 o'clock in the morning, or 12 o'clock midnight, or otherwise known as midnight and noon, there is no AM or PM. It's just 12 o'clock. It's midnight, or it's noon. Strange, but then again, for every rule there has to be exceptions. This is one of those exceptions. We'll now start talking about time zones. Something that you'll be dealing with on a day-to-day basis when it comes to doing forensics, especially if you're in a shop in which you're doing forensics from different part of the country or different parts of the world. Time zones are geographically assigned. So an area or states, let's say in the United States, certain states will all be assigned to be in a certain time zone. It was invented early on by Sir Stanford Fleming in 1888 to help with train schedules. Well, what happened there then is that during the early part of our century in the United States, trains from all over the area used to go on each other's tracks, and they had their own time set. So they believed that they were going to arrive someplace at 3:30. In reality, somebody else thought they were going to arrive there at 3 o'clock. So you have two trains on a track coming head to head. Now, if that had been the case, 3 o'clock and 3:30 would have been a problem. But because they had their own time for an area, and there's thousands of areas all over the United States, you had conflicts and the two trains would come to a station and they both arrived at the same time. And that's why we had a lot of crashes in trains back in the 1800s. So Sir Fleming came up with the idea of time zones across the entire United States based on the area in which you're in, so that everybody arriving at Chicago would be on the same time. Everybody arriving in New York would be at the same time, at least on their watch. There are 24 major time zones, and there are a few weird ones as well, where there's only a half-hour difference. Here are some abbreviations for the time zones in the United States. And we have Atlantic Time, Standard Time. We have Eastern Time. We have Central Standard, Mountain Standard, Pacific Standard, Alaskan and Hawaii Standard. And remember, once a year in all those, you also have daylight savings. And that's when you see the abbreviation, instead of PST, it's PDT, or Pacific Daylight Time. Graphically, that's what the time zones look like when you take a look at it on a map. Generally, they change about every 15 degrees going across the United States. You will notice, though, that in some states, there are areas where the portion of the state is in one time zone and another portion of the state is in a different time zone. Good example is North and South Dakota, Nebraska, and parts of Missouri. The United States, or the continental United States, has 4 time zones. As you can tell, we have Eastern, Central, Mountain, and Pacific. And their difference from GMT is anywhere from 5 to 8 hours. So technically, Eastern time zone, when it's 7 o'clock at night, you subtract 3 hours, and that's what time zone it is, or time it is in the Pacific time zone. There's also some additional time zones for Alaska, Hawaii, the Virgin Islands, and some other of our protectorates like Samoa, Guam, or Puerto Rico. You can see them listed here. You're probably asking me right now, but I'm in the United States. Why would I care about Puerto Rico? You'd be surprised at how many data centers are located in Puerto Rico or in Hawaii that are set to their local time there. Places with special time zones. The following states that I have listed here are 2 time zones within them, and it's usually split down a county line, but that's not always the case. There are areas where you can cross a street and you're in a new time zone. Good example would be Beacon Hill and Mexico Beach, Florida. If you cross a street, just 18 feet of asphalt, you're not only in a different city and time zone. One would be Eastern and the other one is Central. So can you imagine what happens at 2 o'clock in the morning when the bars are supposed to close? Everybody gets up, they go across the street. Hey, it's 1 o'clock, another hour of partying. There have been cases like that in the United States in which a city would actually extend the amount of time they were selling alcohol till 3 in the morning just to prevent the people from walking across the street and giving all that tax revenue to a different city. So, international time zones, they can get even more complicated. As you can tell in looking just at this overall graphics, how a time zone can stretch to the right and left based on islands, or within a country it'd be stretched out or made smaller just to accommodate something special. I love the down under country. You take a look at the map on the preceding page and it looks like everything's pretty well situated and true. But here's an example of Australian's time zone map. Notice that you're correct. They can be in the center part of the country. They have the Northern Territory and the Southern Australia, and they're an hour difference. But they're in the same longitude. Does that make any sense? Or they could be a half hour apart, such as the Northern Territory from Queensland. That's only a half hour difference. So where you go to places you need to research and find out within that country where that computer was located, what was the time zone it was in. And then on top of that, what time of year, because it may or may not have been daylight savings for that area. I know, we're going to skip the rest of the world for right now because it can even get more confusing as you go into China and Russia, let alone Europe. But like I said in the prior slide, when you're researching time zones, make sure you go in and look at the time zones for the country and the city that the computer came from. Because as you can see, even the city can make a difference if it's in one time zone or another. What is daylight savings time? It was actually first proposed by Ben Franklin as a way of extending the day for people to work in the fields. Well, basically, it begins in the United States at 2 a.m. on the first Sunday of April. It reverts back to standard time on 2 a.m. on the last Sunday of October. And all time will change at 2 a.m. local time. In the European Union, daylight savings time begins and ends at 1 a.m. UT, or Greenwich Mean Time. It starts on the last Sunday in March and ends the last Sunday in October. In the EU, all time zones change at the same moment. Think about that. Now we have the United States with daylight savings time at one period of time. Then we have Europe that does it at different events. See how complicated daylight savings is going to start making our lives within the computer world, or cell phones? Since most cell phones actually timestamp to the local time zone they're in. Can you imagine having a cell phone that forgets about daylight savings? What does it do? As if daylight savings wasn't complicated as it was. Of course, Congress has to get involved to really make it really complex and complicated. Back on August 8th of 2005, President Bush signed the Energy Policy Act of 2005. This one act changed the dates for daylight savings time in the U.S. beginning in 2007, so that daylight savings began the second Sunday of March and ended the first Sunday of November. They want to see what kind of an impact this would change on energy and energy production in the United States. Once the Department of Energy study is complete, it goes back to normal time, changing daylight savings dates and times, which it is today. So think about that in your forensic world. You have a computer. Do the acts or the logs reflect a timestamp during this one period between 2005 and 2008? That was in the George Bush daylight savings time period, or did it occur outside of that? Because you could have a date in which there was daylight savings during this period, and if it was 2009, it would not be in daylight savings. Yes, this can get complicated quickly. Oh, I know. Let's make it even more complicated. Let's say that in some places we do not observe daylight savings time. Places like all of Hawaii, or Samoa, or Guam, Puerto Rico, the Virgin Islands. There is no daylight saving times in those locations. This is my second most favorite one that's out there that makes things complicated. Daylight saving time is there inside Arizona. So daylight saving time is observed in the Navajo Indian Reservation in Arizona, New Mexico, and Utah. It is not observed anywhere else in the state of Arizona. So only the Indian Reservation has daylight savings time. The rest of Arizona does not. The Hopi portion of land in the middle of the Navajo Reservation does not observe daylight savings time either. So Arizona does not, the Navajos do, but the Hopi do not. Take a look at that map in the bottom right-hand corner of the slide. You'll see the red for Arizona, the blue for the Navajo tribe, and the little red in the middle for the Hopi. So you could drive for 10 minutes and be in and out of the time zone 3 times. And you thought that was complicated. How about Indiana? Before 2006, 77 of the 92 counties did not change. Those are the ones you see here in white. But 15 of the counties did change, and those are the ones you see in yellow, and the ones in blue. And now that it's after 2006, all of them change.
But here's the best one. After April 2nd of 2006, daylight savings time is in Indiana. Every Indiana county observes daylight savings time. But of course, somebody had to be different. So you have 8 Indiana counties, those listed here. They moved from the Eastern time zone to the Central time zone. So what used to be 3 o'clock in the afternoon became 2 o'clock in the afternoon after the move. So as you can see, when you start adding up zones, daylight savings, the format, it can get somewhat complicated. So that's why you have to always remember sit down, figure out where the time zone is. Are the logs in the local time zone? And if so, convert them to UTC. To help with this, there's a really good web page, which we've listed on the slide, that can help you navigate your way around the world in different time zones. Did they have daylight savings or not, etc. So what can happen if you get a time zone wrong or the conversion of time zone wrong? So what happens if you get it wrong? Ooh, good example. Palestinian terrorists in 1999. The bomb went off early. Now that's getting it wrong. As bombs were being planted, they exploded 1 hour too early. They ended up killing 3 terrorists. Okay, well, maybe that's not a problem. But it can be a problem if it was somebody de-arming the bomb. Here's another example of how the time change can actually cause a riot. What happens when you put young adults and copious amounts of alcohol together? You can have problems. It especially comes through in the fall when time bounces ahead. Remember, spring back, spring forward. So at 1 o'clock, it automatically becomes 2 o'clock, 2 a.m., and the bars close. So they lose an hour of drinking time when daylight savings does the switch. Ohio State University had over 1,000 students one night and late partiers chant freedom as they threw liquor bottles at the police attempting to control the riot. And all that was about the bars closing at what they thought was 1 o'clock, and in reality it was 2 o'clock. As you can tell, even in a manslaughter, or just a traffic accident, but as you see this case listed a manslaughter that occurred in California, and everything was hinged upon was the roadway slick or not at the time of the accident. And it all came down to daylight savings time change. Did somebody adjust for it or not? Turns out in this case, they had not adjusted for it, and the road was slick at the time of the accident, like the driver said it was. So what can you expect for future questions that might be asked by a defense attorney or the other side in a plaintiff lawsuit? Example, in a hacking case or a case where a computer was hacked, when was an OS patch really done? Was it done in a timely manner or not? What date and time? Was it done before or after daylight saving switch? Was a clock manually moved ahead or behind to hide something in a case? There are artifacts that can show that. What was shown in the event logs? That shows that. Or you see an email that is sent and a timestamp on it at the date and time that the person said they sent it. It would be within the daylight savings time, yet it shows standard time on the header. What do applications do? What is a base timestamp that an application will use? Does it use something off the internet? Does it use something, the BIOS clock on the computer itself? A good example of that would be antivirus. When was it run? Was that run based on the timestamp? Did daylight savings make it mess up and not be run on a certain day because all of a sudden time jumped ahead and it skipped a task that it had to do at that period of time? That's how important time can be in these investigations, and why it comes back to you as the analyst to be able to determine when and where and what time period, what timestamp, what zone was used. I know your head's exploding at this point. You're saying to yourself, why did I take this class on time? Like I said, it's very important. But why don't we take a break for a few minutes and then return back after you've cleared off your head, relaxed a few minutes, and we'll go on with sources of time and the remainder of this class. Before we start talking about dates and times and files and things like that, I'm going to speak really briefly about sources of time, what's good and what's bad. Cell phone, tower, internet, atomic, watches, looking up at the sun with a sundial. And actually, sometimes a sundial can be pretty accurate. The best source of time is absolutely the atomic clock. It's the standard by which the entire world goes by. Internet Time Server is an example of that. WWV or WWVB, the radio time. You can find them by tuning a radio or ham radio to either 5, 10, 15, or 20, or 60 megahertz on the radial dial. And you will hear the time clock going, and it will always have a beep on the hour. The official US time from the web is located at nist.time.gov. A lot of people set up their systems to get the official time right from that website. Some other sources of time. Okay, this is going to age some people. What is popcorn? That's the phone number, 767-1212, and it's good in almost every area code inside the United States. If you dial popcorn, you'll see it'll tell you the time. However, a lot of testing's been done on it, and it's not always accurate, especially around daylight savings. A cell phone gets it right from the local cell site that you first get into when you get on the system. It may not be accurate also, because a lot of cell sites are run by independent people, and sometimes they don't log very good clocks inside their cell sites, or they're not getting it from the NIST cell time base. So cell phones you always have to be a little checking on. Radio news start every hour? No, they never start on the hour. They could be 5 minutes late. You never know, because they know you don't have a clock in the car. You're just driving down the road listening to the radio. Observe sunrise, noon, and sunset. No, that's not too accurate. It generally is accurate because you can say, hey, okay, it's sunset, and that usually happens around 6 o'clock. But you'd have to have a timing map that shows your location, latitude and longitude, and where the sun rises and sun sets according to that exact position. You move 2,000 feet away, what happens? It'll be off by half a second or so as to when it's going to pop up. One of the things you can do as a forensic examiner is buy an atomic clock and check it against the NIST.time.gov website prior to going out. I have had quite a few of these in my career, and I can tell you that 1 out of probably 10 was not accurate. And I found that out by literally when I bought it, I compared it to the NIST.time.gov site and saw that it was off by a couple seconds. But generally, they are pretty right on. Now, we learned all that to help us understand when it comes to file systems, dates, and times. So for the purposes of this class, we're going to be talking about the Microsoft family of operating systems. There are very many other operating systems out there, such as Linux, Android, iOS, X, just to name a few. You need to find out about those operating systems, how they handle dates and times. And remember that it applies when an application or system program is operating using the file system standard calls. And there was just no funny business going on. You do realize that an application does not have to use the standard calls to update the date and times in an NTSF or a DOS operating system. They can do what they call custom changes, and they directly write to the files without bypassing the MFT or the DOS operating system. Of course, in the long run, all this relies upon the system clock accuracy or the accuracy of the internet clock they used over the network. One thing you have to keep in mind is that a system clock does lose or gain time over a certain time period. And the file dates and times rely completely on the system clock. Sometimes, and dates inside a file are independent of the system clock. We'll talk about more of about that later, but that's called metadata. You'll see that in programs such as Excel, Word, PowerPoint. So remember, not everything you're going to see now applies. It can change based on the application that you're using. Don't worry about it. It's going to be painless. So let's jump into it. So we can find date and times in directories and folders, in log files, because that's what a log file basically is date and times of events. We can find it within document files. You can find those things even in a picture file, a PSG, or a GIF image. You can find them in memory swap files and databases, and emails, and the headers of emails, and the hidden headers of emails, and on the server email system. You can find date and times in firmware. You can find it in the MFT of an NTFS system. In fact, in the MFT system, there are 9 dates and times besides the general 4 that we're used to, but they can have up to 9. Directory, a folder, it's just the same term used for a different term used for the same thing. Directories is a term that we've used in DOS and also Linux operating systems or iOS, whereas folders is used almost exclusively in the Windows GUI, such as Windows XP and afterwards. In the FAT file system, you'll find MAC dates and times are kept in a directory. The MAT, what is that? That's the modified time, the access time, and the creation time. In the NTFS file system, though, you'll find MACE. MACE refers to modified, access, creation, and entry modified. So let's start off with the modified dates and times in a FAT directory. A modified date and time is basically when that file was last opened to be written to. Now remember, a file can be modified but not modified by an application. Access. Access is the last time the file was opened. It doesn't matter if it was for reading or for modification. Even viewing a file's properties will change the last access date. Now remember, that's the last time the file was opened, not that you actually saw it on the directory. Creation. Creation is the date and time that the file was created on the media and or in a specific partition or directory. So in other words, you can have a file that has a modification date of an earlier time and a creation date of a later time if that file was moved from one partition to another partition. That would mean it was created now on that new partition. It's a brand new file there, even though the last time it was accessed was earlier. There's an additional dates and times under the NTFS file system. For in the prior slides, we've been talking about a DOS operating system, things like we see on thumb drives and multimedia. But on hard drives today, you'll see the NTFS. One of the additional dates and times, there are 9, that they have is entry modified date and time. And this occurs when a change is made to the master file table itself. There is also a file name date and time in MFT. This is the date and time that that file name was first seen in that MFT table or that partition, and it will write that file name there. Why is that important to you? Because you could actually see if the file name, date and time, and the creation date and time are the same, then you know that was the first time that file was written there under that name. But let's say you have a creation date and time that is older than the file name creation date and time. That means that a prior file had that name at some point. The operating system keeps a number of log files with date and times, but here's just a couple that we'll talk about. The info2.dat, which is the recycle bin, event logs like the system application security event logs, and the app log files, index.dat, off items log. The registry entries can all contain created and last modified date and times. Link files, more commonly known as shortcuts, they can contain creation dates and times, modified dates and times, last visited date and times. All those files have date and times within them. So Office document files can contain MAC dates and times, as well as the last printed times of some items. Programs such as Word, Excel, PowerPoint, WordPerfect, Visio, Microsoft Publishing files all contain this metadata that are dates and times where certain events occurred. Now remember, this is relying upon the dates and times taken from the BIOS clock, the computer clock. So you could have a document that was created on a system, and according to the metadata, it was created on one date, but last modified on a previous date. That would be an indication the file has been copied from the original place where it was created. Database files such as Access, SQL, Oracle, and believe it or not, database files include a PST file from Exchange or Outlook. An MBX file would be something that was from the early mail systems of Outlook. Quicken Books or VersaCheck. The individual files within the database can actually contain dates and times also. So once again, it's important to know what database you're working with and where within that database would be the relevant dates and times that you could read and interpret. System swap files can contain date and times from files that are held in memory. Index.dat file are a good example of this. As you look into the Win2K or XP page file system, they can contain date and times in there. For the Windows 95 and 98, it's the Win386 swap file, and for Windows 3.1, that's an old system for the young ones. It's the 386 spart.par or the 386 swap file. Email files is a great source of dates and times. They can be on the received lines that you see. They can also be in the body of the email and in the hidden portions of the email which you do not see normally, otherwise known as the full headers. They can also be independent of the host computer's clock. Those dates and times within an email header can come from the mail server, from any mail server it touched during its process of getting to your laptop or the end system, as well as the server that receives the files, whatever date and time stamp it uses, all the way down to your local PC or phone as to what clock it's using as it's received the mail. Even a piece of hardware, like a hard drive, can contain date and time information. A good example of this is the smart drive data on hard drives. It keeps track of how long the drive has been operating, how many times it's been turned on, etc. Where they can come into play? A prime example would be a fraud occurring on the internet with people selling hard drives purporting to be brand new, and in reality they're refurbished, or they're just cleaned up and then sold. They were seconds off the line, or somebody had the hard drive, it failed because of extreme heat. The drive is reformatted and then resold and being told to people that is a brand new hard drive. By using the correct software, which you'll actually obtain in this class, you can look at the smart drive data on a hard drive and actually determine how many hours it's been in operation. I had a case just like that one time where I was given 10 drives, and these drives were being sold as purported to be brand new drives. In all reality, all of them had been used for 10,000 hours plus. So instead of paying an $80 fee for the hard drives, they were selling them for the normal $350 to $400 each. Dates and times are normally calculated from encoded values, but there's a number of ways this has been done. But in the long run, just remember, it all comes down to just doing a little math, and there's a lot of programs that are made to automatically do this for you. So yes, we need to now talk finally about encoded dates and times. How many different types are there, and what's available to help us in dealing with them? I know what you're thinking right now. After going through this whole thing on time, yes, it would be nice to have a couple drinks right now. But what I'm trying to tell you here is there's very many different ways in which date and time formats are written. So as you can see, there's quite a few that are different. And then again, they're used specifically in different files or different parts of the operating system. Just to think about the Windows cookie, they have a low-high value, which you have to reverse to figure out the date and time. The Unix numeric is probably the most widely used one, along with the Windows file time. That's why programs like the EnCase, FTK, or WinHex are nice. They do all the hard work for us in interpreting a timestamp and putting it into a format that we can actually read, otherwise known as human-readable code. The thing for you to remember, though, is understand what they're doing. It's one thing to use a tool. It's another thing to explain to a jury, this is what the tool is doing for us automatically. And that you've checked it, and you know that it's accurate and correct. Can it be hard to decode a window and date time format? Sure it can be, because there are so many of them. But lucky for us, we have people that write those programs as free tools. A good example would be Craig Wilson, who provides a free tool for this. He's at digital-detective.co.uk, and it's called the decode.asp program. As we wind down here, just remember that each application or operation will affect the date and time differently. Good example would be, instead of setting your time to London, who does observe daylight savings time, set it to Casablanca, which does not acknowledge daylight saving time. So this concludes our initial class on dates and times. You should now have a really good foundation on time and dates and its many formats, especially in the forensic work area. In the forensic work area, this is the most single important element in explaining why certain data is significant in a case. A piece of data may be significant in a specific time period when it's not in a different time period. That concludes A Wrinkle in Time.